I would like to call my guest to come and talk us on Legionella in hospitals, right?
Yes, hospitality. Yeah, that's right. Good evening, ladies and gentlemen. Kalispera. I'm extremely thankful to the ASHRAE Hellenic chapter for the opportunity to say a few words about a subject I'm very passionate about, Legionella management. Efaristo. I will give you a brief overview about what is Legionella, why we need to worry about it, what is ASHRAE standard, the latest standards being worked on say about it, and take you through a few solutions. So the topics I'll briefly cover is what is Legionella, a brief background, the tracking of the bacteria, Legionella bacteria, and the disease called the Legionella disease. What are the risk systems in the hospitality sector? Because Legionella is quite a deep subject. It affects all built environment, be it any kind of a colony, be it a hospital. But I will focus a little bit on the hotel sector, which is growing rapidly across the world, and where it's extremely important to understand this bacteria and its disease. We'll talk about standards. I'll talk, why is ASHRAE 188201 such a big deal? We'll look into that. We'll see what the standards recommend, a plan, what are some of the disinfectant strategies to control this bacteria. A little bit about the disease diagnosis, medical diagnosis, and the treatment, and we'll see what we can learn from this by concluding. So, what is Legionella? Most of the audience heard about it? Oh, good. Because 10 years ago in India, it was all Greek to me. But today I'm in Greece, and it's Legionella to me. So, it's a gram-negative bacteria. If you test in the microbiological lab, it's gram-positive, gram-negative, so it's gram-negative. It's aerobic. We all know what's aerobics. We try to increase our cardiovascular fitness by doing aerobics, so they are oxygen-loving. So if somehow the water does not have oxygen, they cannot survive. They are prevalent in nature. Nature has bestowed this bacteria in natural waters. If you go along Athens or anywhere else, see nice streams, rivers, lakes, the bacteria exists. It's nature has bestowed in a very nice way that it has its own ecosystem. There are other bacteria which feed on Legionella. Legionella feeds on slime. As you go into higher life forms, and the entire balance is maintained. It just survives by itself. It retains its levels. It retains its levels to such a point we call it non-infective, and we learn how we make it grow. It has a high colonization capacity, which means that it can grow very, very rapidly. Various standards across the world, ASHRAE standards, other standards say that 10 is a very low limit, 10 to 100 is medium, above 100 is very harsh, very high. But we must learn to understand that the very time you get a positive, a 0.1, a 0.5 colony forming units per limit, it can colonize very, very quickly. In a matter of days, it can shoot about 10 and 100. So it colonizes very, very quickly. So origins. What is this word Legionella? A lot of people in India and across where I've spoken, they wonder why this word. You see, what happened in 1976, more than 40 years ago, there was a conference, just like we have a conference here. They met in a hotel in Philadelphia, and the conference was attended by American soldiers. The American soldiers are called Legionnaires. So there was a legion, an American Army legion, which attended the conference. More than 2,000 attendees attended it for several days, 3 days. And at the end of the conference, they found that within a week, more than 211 fell sick and had pneumonia-type symptoms, high fever, body ache, and weakness. And more than 23 people died. So it was very, very shocking. The medical fraternity, the engineers, everybody was trying to understand what is this kind of disease which has hit this conference. And it took them more than 8-10 months, almost a year, to understand that you see this hotel, this is Bellevue Stratford Hotel in Philadelphia. Atop were cooling towers. The cooling towers were not disinfected properly. The water was not treated well. And they found that the Legionella was traced in the cooling towers, which was taken into the air conditioning, central plant air conditioning system, and through the vents spread into the hall, and that's how the infection came. So this is a background of how the name came about. This is how the name Legionella was given to this bacteria, because it's connected with the American Legion. So any living organism, any microorganism requires it has certain requirements to survive, to thrive. 20 to 45 degrees is the temperature at which the bacteria can survive or can thrive. What are its food sources? The bacteria feeds on slime, corrosion products, scale, silt, any kind of dirt. It prefers stagnant conditions like most other bacteria. So the temperature range, as I mentioned, 20 to 45 degrees, optimum temperature for the bacteria to breed, grow. As you raise the temperature from 45 to 55, 55 to 65, initially the colonization capacity is stopped. It cannot reproduce. As you go more than 55 to 65, it starts dying, and say about 70 degrees centigrade, there's a rapid kill. It just cannot survive. So this gives us an indication, a solution, how we can control the bacteria. It's called temperature stratification. If there is an opportunity to raise the temperature of the water for even a little time, about 70 degrees, a few minutes, you can get rid of it. So this is one aspect of controlling this bacteria. So route of infection. A lot of people ask me, when I drink contaminated water, can I get Legionnaire's disease? No. Legionnaire's disease is spread through aerosols. Aerosols are water droplets, which are created not only just in cooling tower drifts, but a lot of other water systems. Whenever the air or the water blows over the water, there are droplets thrown into the air. And when one inhales those contaminated water droplets, you get the bacteria then get into your system. They are sucked into through the nasal tract. You breathe them in. It goes into the alveoli of your lungs, and it embeds in the alveoli, and they start growing. So aerosol inhalation is the route of infection. You have to breathe it in. It's a respiratory infection, which this bacteria causes. Aspiration. We all know, we all have aspirations here. Aspiration has got two meanings. One is a medical, one is non-medical. Non-medical aspiration is goals, having high ambitions. But in the medical terminology, aspirations means actually breathing, sucking in air droplets through your nasal tract. A condition occurs when you have hiccups or when you're drinking water and you choke on it. That is the time when the contaminated water enters the nasal tract, goes down into your lungs and gets infected. So the only time you can have a Legionnaire's disease infection by drinking water is when there's a phenomenon of aspiration. That is choking or having hiccups. So what is the profile of people who get infected? Research has shown that males, women are luckier, men are more prone, who are 55 years old and who are smokers. Smoking causes lungs to weaken, and therefore this is a lung disease, a respiratory disease. So male smokers about 25 are the most prone. So how big is the risk? The risk is huge. From 2000 to 2014 in America, there's been a growth by 400%. In 15 years, 400%. More than 10,000 reported cases, and more than 5 times that unreported across the world. And out of that, 15% are dying. So you can imagine the risk. So how do we analyze the risk? We have something called the unholy trinity. All right. You need to have, first of all, you need to have aerosols being produced, because without the water droplets being thrown in the air, you cannot inhale and you cannot get this infection. You need to have biofilms. A biological film is a nest for the bacteria to breed, which gives it nutrition. It gives it the environment to grow. And thirdly, you have a susceptible population. I say this because in hospitals and hotels, you do have profile of senior people, senior and elderly, who have a history of diabetes or other cardiovascular disease. And when one such has disease, the immunity automatically goes down. We call them immunocompromised, immunosuppressed. Some people have, HIV or cancer, they're completely suppressed. So when the immunity system weakens, you're open to any kind of disease. So if you have the susceptible population, male smokers above 55, who otherwise are having immunosuppression, some immunity problems with disease, if you have aerosol exposure and you have biological films, biofilms, then you have the perfect mix for this bacteria to grow and the disease to happen. So as I mentioned before, it's nothing but a pneumonia, a bacterial pneumonia. As in medical terminology, you have viral and bacterial. So it's a bacterial pneumonia. It has a 10 to 15% fatality rate. That means 15% of the people who are infected can die. Approximately 10,000 cases globally, and the incubation period is 2 to 10 days. So it's very interesting because, especially in the hospitality sector, if I stay in a hotel A and I stay there for 3 days and I move to hotel B, I stay there another 4 days and I go back to my home country, and then I discover that I've been infected with Legionella. If I get all kinds of symptoms, I go to the doctor. I could have got it from anywhere, ABC, including my home country. So how does one understand? So we'll get to that. So 2 to 10 days incubation period. It makes it very tricky to identify the source. So just to focus on the symptoms, it's a respiratory disease, it's a pneumonia, it's a type of pneumonia. So you could have fever, chills, body ache, again diarrhea as a subsymptom. So muscle aches. So if you look closely at these symptoms, it can be very misleading. You could have a general flu, influenza, and still have these symptoms. So even medical professionals are thrown out of gear. They have to really do the tests repeatedly to make sure if a patient doesn't recover in time, one of these tests have to be done. So it's misleading. It can be confusing because common symptoms. Systems at risk, I'm talking about hotels in general, all kinds of water systems, not just cooling towers. Fountains can create aerosols, jacuzzis can, simple showers can, and faucets, any kinds of faucets, including a wash basin, as basic as that. So if the water is contaminated in the building, in the hotel, any of these systems could grow the bacteria and proliferate the disease. These are some more sampling points. I mentioned earlier that one of the key requirements is a biological film. Biofilm, as we call it, is a culprit within the pipelines which supports the growth of bacteria, without which it cannot really grow to viable numbers. Viable numbers are those numbers with which the infection occurs. So what is a biological film? Okay, it's a porous matrix of scale formed by the accumulation of sediments from a galvanic reaction between the dissolved minerals and the metal surface. So in this film, the algae start getting embedded. The bacteria feed on the algae, they have the right ambience, they grow stronger, their numbers increase. So if a pipeline is not maintained, if the water is not disinfected, if you don't have proper flushing of the lines, a biological film can be the first step, one of the key steps in which the bacteria can start growing. So it's very, very important. Just to show you how a biological film can create problem, especially as I mentioned earlier, the bacteria thrive in stagnant conditions. So if you are having a project where you're either building more rooms for your hotel or for your hospital or any kind of building, you shut down a wing, shut down the water side of that wing to continue to repair or build up more rooms, then stagnation occurs. And the green part which you see is the film which has occurred because there is no proper disinfection happened. When you restart the project without taking flushing into account, without disinfecting the pipe, the green portion, the biological film gets pushed out and your microbial contents come out of the faucet. Now if there's a spray happening, if there's a shower, a wash basin, a health faucet, what have you, it gets thrown in the air and the person who is using that water can get infected. A simple pipe system, cross-section, it shows you a biofilm right there. A filter media, the very purpose of having a filter is to purify the water. Now if the media is not serviced, it's not backwashed, it's not checked to whether it's clean, the filter media can develop a biofilm and cause the Legionella bacteria to grow. This is the typical cooling tower cross-section. Why are cooling towers at risk? A lot of HVAC engineers here, I want to emphasize that it's one of those equipment which are causing a Legionella risk. If the water, circulating water in the cooling towers is not disinfected appropriately. The ASHRAE standards gives you guidelines on how to disinfect water in the cooling towers. So why are cooling towers a huge risk? Because they have ideal temperatures, 20 to 45 degrees typically, we maintain. Nutrients are available. You will see a lot of water-cooled chillers having cooling towers, having some element of algae, some biofilms created because of that algae. The other nutrients are available, not just algae and slime, but corrosion and scale are typical issues which we face in water-cooled chillers. And corrosion, scale, biological films, algae, slime, all these together with dirt form the nutrients for the bacteria. They are located near large populations, be it a hotel or hospital. The cooling tower drifts which come out of the exhaust area can carry the viable count of the bacteria for several hundred meters. So if the cooling tower is located near the guest area or near the patient area, it becomes a high-risk situation. Stagnancy exists in pipelines. There are dead zones. So anywhere there's stagnancy, again the bacteria can grow. And lastly, the drift is a natural part of the cooling tower in the equipment itself. The drift is itself an aerosol. It causes an aerosol. So it gives you a lot of factors which are making Legionella bacteria grow. And therefore, cooling towers are one of the very high-risk systems. You can see here the cross-section. You have algal fouling, you have corrosion, you have scale, and all three are nutrients for the bacteria. A simple causation chain, any disease has a causation chain. So you get your water from the water supply, it gets cooled in the cooling tower, there's an aerosol created from the cooling tower, there is a population, and if there's a susceptible population, be it a hospital or be it a hotel with senior people who are otherwise immunocompromised, they can get the infection. Once again, you can look from the HVAC standpoint. If you have an air handling unit which is positioned fairly close to the drift, it can get sucked in to the air intake. So how do we stop it? How do we control? In cooling towers, proper design. Location is very, very important. Make sure it's away from the guest area if it's a hotel, away from the patient area. Effective water treatment. When I say water treatment, that's just not bactericides, not just biocides, but treat for corrosion, scale, and microbiological fouling. It should stop the slime, algae, all kinds of bacteria. How do we do that? Periodic, other than treatment, periodic biological flushing and mechanical cleaning. So you have to have the cooling towers cleaned in a frequency recommended by the standard, and the system of cleaning is also explained in the standard. How do you flush it? How much halogen do you maintain? So minimizing the risk of transmission from cooling towers to people, So locate the trawls, minimize the tower drift. The cooling tower will not be a cooling tower if it doesn't have a drift. So the way you minimize it is you have installed a drift eliminator. To a large extent, you can reduce drift. Keep the drift away from air intake pathways to potential hosts. So if you don't have an air intake nearby, your issue is under control. Locate the towers to keep outside sources of plant life for nutrients. So these are organic matters which can support the growth, their nutrients. Any workers, any on-site workers, you should give them appropriate respiratory masks or respirators so that any drift exposed, they are safe from that. Now, Legionella control standards. We'll get into the ASHRAE part, but before that, we are in Europe. So let's talk about HAC, Health and Safety Executive. There is an approved code of practice in UK and Europe, which now defines the Legionella disease as preventable. It's very important because when a disease is defined as preventable, it says that it could have easily been detected and avoided. And therefore, the management or the owner of the property is entirely responsible. There can be criminal charges pressed against the management and the owner. So this is highlighted as it is defined as preventable in the Health and Safety Executive in Europe. This is the standard 18080601 This released 1.5 years ago. It was a position statement, 12/2000. What speeded up or accelerated this standard in 2015 was an outbreak in New York, Bronx County, where there was a lot of people who died, who fell sick, and therefore this was expedited. As we speak, there are changes going on in the position statement, and this is also open for revision every 3 years. We have a small subcommittee of ASHRAE, which is the Indian counterpart, and we are now working on how we can give suggestions to improve or to make some changes and revisions in the standard. So why is it a big deal? Once again, Legionella is now defined and comes under the OSHA. OSHA is the Occupational Safety and Health Hazard Association of America. It is now defined as a recognized hazard. Once again, it gives it a legal footing. Till date, if somebody got Legionella or Legionnaire disease, fell sick, died, it was a long legal process to prove whose fault. How did it occur? Not now. Now it means that it is a recognized hazard. You can press charges that the victim or the patient who's fallen sick gets preference. You have to prove now that you have enough mechanisms that it did not occur in your property, in your tower, in your water system. So it gives a lot of legal bondage and legal weightage. That is very, very important, ASHRAE. Hospitality sector, it's becoming very, very important in the hospitality sector because there are a lot of senior people traveling. Hotels are now forced to become compliant because the brand image is at risk. Any small hotel of, say, a major brand like Marriott or Radisson or Hyatt, somewhere in a smaller town they have a small hotel, and if they're not taking care of it and somebody, God forbid, dies, the entire brand is at risk. So that's how it's important. So what do these regulations recommend? Whether it is Health and Safety Executive or whether it's ASHRAE, they say you should develop a Legionella management plan, and keep a focus on preventive maintenance, have environment assessment, that is a hazard investigation and analysis, and sampling and validation. There are 3 things. The 3 are in depth. I will try to come back if people are more interested because of paucity of time. But preventive maintenance, and very briefly, is you must take care of your water systems, make sure the treatment is right, make sure the flushing is right. You have to have an assessment, get an expert before you start treating, or even after you start if you haven't treated as well, to understand which are the risk systems and what are the hazards involved. And finally, you have to do adequate sampling as defined by the standards, the frequency, and the validation has to be supported. The testing has to be done by accredited labs. So as I said, OSHA suggests that less than 10 colony forming units is very small, 10 to 100 is moderate, and greater than 100 is large. So less than 10 people don't want to worry about it, but as I said earlier, the uniqueness of this bacteria is to multiply, colonize very, very fast. So even if you get any factor which is positive, 0.5, 1, it can be disastrous. Within days, you can have between 10 and 100 and get into problem. CDC recommends certification for labs. You should go to elite certification labs or government-approved labs. A simple management plan, which is highlighted in the ASHRAE as well as other standards, is if you have cooling towers, follow a certain flow chart. If you have domestic water, follow a certain flow chart. If you have a disease which was indeed identified, then you follow a certain flow chart. In the end, continue to preventive maintenance and routine sampling is a must. So very broadly speaking, if you have a cooling tower, a certain value is recommended. If you go above a certain count, they give you a methodology. In domestic water, if you have anything above nil, you have to jump to the treatment and they give you a certain methodology. If the disease was identified, you have to notify the health department and consider disinfection of the whole property. And so this is a chart, a brief chart recommended in the standard. So let's talk about solutions in a minute here. Minimize aerosolization. Like I said, you have to control the drift. One strategy is drift eliminators or cooling towers. Avoid the temperature, 20 to 45, not easy, especially in tropical zones where I come from in India, 20 to 45 is ambient temperature across the country. So every water in every tank, in every pipe is 20 to 45 degrees. Now what we do is we try to raise the temperature from the boiler, from the hot water generator to be above 50. We set the thermostat in such a way that the return temperature is remaining above 50. There's a little bit of electricity loss, but we at least control the temperature part of it. Avoid material which harbor. EPDM is a type of rubber. Research has done and shows that pipelines with this EPDM can harbor the bacteria. Maintain cleanliness of spray outlets, whether it's a shower head or tap, health faucet, any kind of outlet. Must flush it, must sanitize it, must disinfect it. The standards give you the procedures, how to sanitize. Sound water treatment programs. You must control corrosion scale, all kinds of biological growth in any water system you have, including cooling towers. Flushing regime for rarely used outlets. You have hotels which are off-season. Sometimes guests don't occupy a certain wing. Make sure that your flushing is done at routine frequencies, which otherwise the equipment will start having deposition, scale, and start harboring bacteria. So very broadly, running out of time, so what are the strategies to disinfect? Heat. As I mentioned, this bacteria is heat sensitive. So if you have an opportunity to operate above 50, you should. If you are infected, then you must consider raising the temperature to about 65, 70, at least for a day or two to eradicate. Chlorine and BCDMH. BCDMH stands for bromochlorodimethyl hydantoin. These are some of the chlorine. They are halogens. They are bromine. Bromine is a more effective halogen in a given pH range. It has a wider sustainable capacity, and it attacks Legionella bacteria better than chlorine. And Chinese researchers have identified that Legionella bacteria can withstand low levels of corrosion, which is otherwise done in municipal water supplies of 0.2, 0.3. So for example, swimming pools can generate aerosols, but the chlorine levels are maintained around 1.5, 1.5. Therefore, the bacterial levels are unheard of or very rare in swimming pools. But if you have a general water system which you get from your municipal supplies, from the government, the chlorination level may be there, but very low. It's not enough. So other strategies are chlorine dioxide, copper silver ionization. You have specific biocides called isothiazolene, which are used for cooling water treatment. Ultraviolet and ozone are the later technologies which have come into pools and all other systems. A quick look at the diagnosis. So how does we are not doctors, but to give you a broad idea, the urine test can give it, the lung washing, and the sputum test, the spit. So all these three can be collected and taken to a pathological lab where they can actually trace the bacteria. Treatment, Arilox, erythromycin. These are typical antibiotics. So to conclude, we must remember the disease is fatal. 15% fatality rate. So if there are 10,000 cases, 15% are dying every year. The disease is growing. Aerosol dependent. It's So any water system, equipment which create aerosol is a risk system, be it a shower, cooling tower drift, any kind of spa, any water system which produces even a sprinkler in a gardening hose. ASHRAE 2015 specifies Legionella as a recognized hazard. Legal bondage here, not easy for somebody to say, I didn't know about it, or he has to have perfect documentation. He has to follow the standards for flushing and treatment as per the guidelines. You could not say that I've taken care of it. So everything has to be done and documented in the formats suggested in the guide, in the standard. Okay. Infection control, as the standards specify, European and ASHRAE, a simple management plan which I had highlighted. You follow the plan, you get an expert to identify your water systems, your risk areas. You make a plan for treatment, augment the treatment if it's not already there as per the standard, and then validate your checking and document as per the standard formats. Talk about hospitality sector, compliance is now not an option. As I said earlier, if there is even one case in the country, then the whole brand is at risk. So the future is that, for example, India now, all the smaller standalone hotels are all merging with multinationals. We have Hyatts, we have Radissons, we have, across the whole country. And if any small town, if somebody's not, a franchisee is not taking care of his water, the entire brand is at risk, and the business is at risk. So these are some of the acknowledgements for my notes, and thank you very much.